Hey guys, Nate Morris, MasterLSAT.com. In this video, we are going to get some practice doing assumption questions. We're going to work through this question up on the screen and learn some valuable skills for assumption questions. So if you like this video and you find it useful and you want to see more content like this, definitely consider liking, subscribing to my channel. And if you're really ambitious about hitting a top score on the LSAT, you're going to definitely want to check out my course, which is over at MasterLSAT.com. My course is really, in my humble opinion, of all the LSAT courses out there that I've seen, it really is the best, it's the easiest, and it's the most effective for hitting a top score in the 170s as quickly as possible. And it also happens to be insanely affordable, so you're definitely going to want to check that out if you're serious about getting a top score on the LSAT. Anyway, back to the matter at hand. Let's look at this question I have up on the screen. Now, this is an assumption question. This was modeled after an actual question from an official LSAT that I know a lot of people miss. I just changed some of the words and sentences around. But the truth is, it's really modeled after a ton of LSAT questions. There are so many assumption questions on the LSAT that you're going to see that are essentially exactly like this question, which means if you have trouble with assumption questions, well, if you can get really good at this question using the skills that we're about to learn in this video, if you can really master this question, then you've essentially mastered a ton of other LSAT assumption questions as well that you're going to see on the test. So why don't you start by having a crack at it on your own, see if you can work through the question on your own, try to predict the answer before you go to the answer choices, try to figure it out, do the math in your head, figure out what the answer, not literally math, but you know what I mean, try to do the thinking ahead of time in terms of what you think the answer is supposed to be, then try to find that in the answer choices, do the best that you can, and when you're ready, you can unpause the video, we'll work through it together. Okay, so let's take a look through this question. So what's the first thing that you do? You always read the question first so that you know what your goal is. So the question says, which of the following, if true, allows the conclusion of the argument to be properly drawn? Which means we're going to fill in a hole in the argument. Which of the following is going to prove the conclusion? It's a missing hole in the argument that once we assume this thing, it's going to prove, it's going to allow the conclusion to be properly drawn. So we're looking for an assumption. We're looking for a missing assumption in the argument. So let's see if we can read the paragraph and look for that missing hole. Now, we always like predicting the answer ahead of time when it comes to logical reasoning, but specifically assumption questions like this one are among the more predictable ones, right? Because there's always going to be a hole in the argument, and in theory, we should be able to find that hole and therefore predict what the missing assumption is. So let's read the paragraph together. It says, an ecosystem needs access to nutrient-dense soil in order to sustain itself. Therefore, an ecosystem cannot be sustainable without a wide variety of saprotrophic decomposers. After all, soil can be nutrient-dense only if chemical nutrients are recycled from dead plants and animals and released back into the soil. So first of all, step one is always identify the conclusion, right? What is the thing, the bottom line, the conclusion of this argument that we are trying to prove? And the answer is, it's the middle sentence. Right? An ecosystem cannot be sustainable, sorry, my sloppy underlining, cannot be sustainable without a wide variety of saprotrophic decomposers. Right? It's preceded by the word therefore. That tends to indicate that we are introducing a conclusion. In this case, it's the main conclusion. It's the thing that this argument, that this paragraph is trying to prove. And the first sentence and the third sentence are both brought as support for this middle sentence. So we have to sort of take what we know from the first sentence and the third sentence and see how far that gets us. And if we know all that, what's still missing? What do we still need to know in order to prove this conclusion? So as you can see, this is sort of a chain of a bunch of different information that's linked together. And so therefore, I'm going to diagram this out. It's very good to think about this as far as getting from point A to point B. We are trying to prove something about ecosystems, that in order for an ecosystem to be sustainable, you need a wide variety of saprotrophic decomposers. And then we have a bunch of information given about sustainability of ecosystem. And clearly there's things that are going to link together here. And we're going to have to find the missing link. So what I'm going to do is I'm going to diagram this out. I'm going to show you how to visualize a question like this. You're going to see a lot of other chain assumption questions like this on the LSAT. And I don't necessarily recommend diagramming it out every time you see a question like this. But what I do want to show you is how to at least visualize it in your mind. Now, if you feel like you have to diagram it out, to help you, at least at the beginning, that's totally fine. But eventually the end game is to try to be able to do all this in your head. But at least we want to see how to visualize it. So let's start with the conclusion. We are trying to prove that a sustainable ecosystem needs this wide variety of saprotrophic decomposers, whatever that even means. So let's consider that the bridge that we're trying to cross. We're trying to get from point A to point B. We're trying to prove that a sustainable ecosystem, we're trying to get from there all the way over to wide variety of sap, I'm just going to write sap deck, wide variety of saprotrophic decomposers. So that's what we're trying to prove. Now, let's use information in the paragraph to try to fill in some of that bridge and then see what the missing tile of the bridge is. So essentially, in order to have a sustainable ecosystem, we're going to need a wide variety of saprotrophic decomposers. Now, according to sentence 1, we do know something about what a sustainable ecosystem needs. So that's going to be the start of our bridge, right? The first sentence says an ecosystem needs access to nutrient-dense soil in order to sustain itself. So, and that's used as support. That's one of the supporting pieces of information brought for this conclusion. So, in other words, that's going to be the first tile of our bridge. What they just told us, and I'm going to sort of construct the bridge underneath here, they just told us that if you want to have a sustainable ecosystem, you're going to need to have nutrient-dense soil. Nutrient-dense soil. And the structure of this question is going to basically be like, well, in order to have this, I'm going to need, in order to have A, I'm going to need B, and in order to have B, I'm going to need C, and in order to have C, I'm going to need to have D, and therefore you can tie everything together and say, well, therefore, in order to have A, I'm going to need to have D, right? Think about it. Let's say I say in order to be in a good mood today, I'm going to need to have a cup of coffee. And in order to have my cup of coffee, I'm going to need to go to the store to buy the coffee ground. And in order to go to the store to buy the coffee grounds, I'm going to need to have money in my wallet, right? So therefore, if you put everything together, at the end of the day, that proves that in order to be in a good mood today, I'm going to need to have money in my wallet, right? Because I'm going to need to have a bunch of other things that need the money in the wallet, right? So you can chain those things together. And just like it makes sense in the example that I just gave, it's going to make sense in any example. That sort of transitive property of necessary conditions, whatever you want to call it, is going to always be true. If A needs B and B needs C and C needs D, well, then therefore you can prove that A needs D. In this case, we're trying to prove that A needs D. In a sense, we're trying to prove that sustainable ecosystem requires a wide variety of saprotrophic decomposers. So therefore, we're going to try to construct the bridge along the way and see where that gets us, see what the missing link is. So we know that a sustainable ecosystem requires nutrient-dense soil. And what's the only other piece of information given? It says, after all, soil can be nutrient-dense. So nutrient-dense soil requires, what does that require? According to the last sentence, if you want to have nutrient-dense soil, you need chemical nutrients to be recycled from dead plants and animals. Chemical nutrients, I'm just going to write it, chemical nutrients recycled from dead plants and animals. I'm just going to write chemical nutrients recycled. So in order to have nutrient-dense soil, you need to have chemical nutrients recycled. So what we've done is we've taken all the information in the paragraph, we've diagrammed it out, and you should be able to visually see what the missing assumption is, because there's one of these chain links is missing in order to get to the conclusion, right? So a sustainable ecosystem, if you want to have a sustainable ecosystem, then you're going to need a wide variety of saprotrophic decomposers. How do we know that? Because if you want to have a sustainable ecosystem, you're going to need nutrient-dense soil. And if you want to have nutrient-dense soil, well, according to the last sentence, you're going to need chemical nutrients recycled. So what's the missing assumption? We're clearly assuming that if you want to have chemical nutrients recycled, you're going to need to have a wide variety of saprotrophic decomposers. This, my friends, is the missing assumption, right? If you do all the math, if you line everything up, you'll see that that is the missing assumption. And as long as you assume that, then that proves that a sustainable ecosystem requires a wide variety of saprotrophic decomposers. The way we drew this out, right, we're trying to get from here to there. We're given enough information to get from here to there, and then from there to there, but we're missing the information to get from here to there. And that's the assumption. The assumption is that if you want to have chemical nutrients recycled, you're going to need a wide variety of saprotrophic decomposers. That's the only way to do that, right? And not to get too granular and technical here, but the way we usually use these arrows is that the end of the arrow is the necessary condition, and the beginning of the arrow is the sufficient condition. Again, not to get too technical, but this is consistent with the way that we would usually use this sort of arrow notation on the LSAT, where the thing at the end of the arrow is required for the thing at the beginning of the arrow, right? So we're trying to prove that the wide variety of SAP deck is required for a sustainable ecosystem, and we fill in with these mini required conditions along the way to prove that. So the missing required condition is that a wide variety of SAP deck is required for chemical nutrients to be recycled. So let's look for that in the answer choices. If you want to have another crack at the question now that we've done that breakdown, see if you can find that answer that says that in the answer choices and see if you can get the question right. Even if you feel a little unconfident about your work before, see if you can try it again now. Maybe pause the video. Okay, let's look at the answers together. We know exactly what we're looking for, and like many LSAT questions, once you know what you're looking for, you kind of just have to have the mental fortitude to slog through all the other junk that is going to be thrown at you, kind of like Andy Dufresne at the end of, what's it called, Shawshank Redemption. So you have to be very confident in your prediction. They're going to throw a lot of wrong answers at you. They're going to throw a lot of junk that's going to look tempting. It's going to have a bunch of words from the paragraph, but you know, you did the math, you did the thought process that we just did. You know that we're looking for an answer that says, in order for chemical nutrients to be recycled, you need a wide variety of sapotrophic decomposers. That is the missing assumption and nothing else. Let's look for an answer that says that. Now, A, an ecosystem will be sustainable if its soil is nutrient dense. That's a very tempting answer, but it's not what we're looking for. First of all, the main reason it's wrong is that it's not what we're looking for. It doesn't fill this gap, right? This is a gap, right? This arrow here was not actually filled in by the paragraph. That needs to be filled in order to prove this conclusion. So A doesn't fill in that gap. What A really does is it focuses back on these two things. We already know that if you want to have a sustainable ecosystem, you need nutrient-dense soil. Now, A says not only do you need nutrient-dense soil for a sustainable ecosystem, but it will definitely cause that ecosystem to be sustainable. It says an ecosystem will be sustainable if its soil is nutrient-dense. So again, if we want to use the sort of the terminology of logic, what A is telling you is that not only is nutrient-dense soil necessary for a sustainable ecosystem, which we already know from the paragraph, A tells you it's also sufficient to have a sustainable ecosystem. It's enough to know that you will definitely have a sustainable ecosystem. All of that doesn't matter, right? Because that doesn't help us fill in this gap over here, and therefore that is the wrong answer. Let's go ahead. I'm just going to erase some of these circles just so we have a little bit of a neater page here. Let's go ahead and look at B. Does B prove the conclusion? Without a wide variety of sapotrophic decomposers, so in other words, without this, chemical nutrients will not be recycled from dead plants and animals and released back into the soil. So without that, you won't have this. That's exactly the gap we're looking to fill, right? This is another way of saying that if you want to have chemical nutrients recycled, the only way to do that is to have this wide variety of sapotrophic decomposers, right? Well, if you know that, well, then we know that without A, you can't have, that in order to have A, you need B, and in order to have B, you need C, and in order to have C, you need D, assuming that, let's just say that this is A, B, C, and D, right? We already know that in order for A, you need B. We already know that in order for B, you need C. The paragraph told us those two things. Now, answer choice B tells us that in order to have C, in order to have chemical nutrients recycled from dead plants and animals released back into the soil, you need D. You need the wide variety of sapotrophic decomposers. So therefore, that ties everything in full circle, and therefore now we can prove our conclusion that in order to therefore have A, you're going to need D. So B is the correct answer, right? B is what we need to know in order to fill in this argument, in order to prove the conclusion, and therefore that's exactly what we were looking for. So let's go ahead and look through the other answers and see why they're wrong. C says all ecosystems that have a wide variety of sapotrophic decomposers will be sustainable. That's a very tempting answer. Much like A, what that's doing is reversing the logic for something. It's reversing the necessary and sufficient component of a condition that is part of the argument. So we are trying to prove that in order to have a sustainable ecosystem, you need to have a wide variety of sapotrophic decomposers. Remember, the necessary condition was at the end of the arrow. So in order to have A, it's necessary to have D. That's what we're trying to prove. In order to have, right, that's the conclusion. If we could just go back to the paragraph, that's what the conclusion says. An ecosystem cannot be sustainable unless you have this wide variety of sap deck. Now, C says all ecosystems that have a wide variety of sapotrophic decomposers will be sustainable. that does not prove that they need those to be sustainable, right? That is taking our conclusion and it's switching it around. It's turning it from a necessary condition, which is what we're trying to prove. We're trying to prove that SAPDEC is necessary for a sustainable ecosystem. C is saying that it's sufficient for a sustainable ecosystem. It's saying any ecosystem that has that will definitely be sustainable, right? Those two things are not the same. And I know it's really tricky depending on, how long you've been studying the LSAT for. It kind of seems like those two things are saying the same thing, but they're really not. And let me just illustrate that with an example, right? Clouds are necessary for rain. There needs to be clouds in the sky for it to be raining. That doesn't mean that if it's cloudy, it will definitely be raining, right? That doesn't mean that if there's clouds, there definitely will be rain. That would be clouds are sufficient for rain. That's not true, right? Clouds are necessary for rain. You need there to be clouds for there to be rain, but clouds might not prove that it definitely will rain, right? So those two things are not the same thing. And so too here. We're trying to prove that A is necessary for D. That D is necessary for A, is what I meant to say. We're trying to prove that a wide variety of SAPDEC is necessary for a sustainable ecosystem. C tells us that it is sufficient, that all ecosystems that have that, that's sufficient to know that they definitely will be sustainable. That doesn't prove that they're necessary, right? In other words, if I eat an ice cream cone right now, I will be in a good mood. That doesn't mean that I need to have that ice cream in order to be in a good mood. Maybe if I do some yoga or something, or if I play a game of Duck Duck Goose, maybe I'll also be in a good mood, right? So just because something is going to get me into a good mood doesn't mean it's required. So too here, just because a wide variety of SAPDEC is going to make it a sustainable ecosystem doesn't mean it's required. Doesn't mean the ecosystem cannot be sustainable without that wide variety of SAPDEC, which is the conclusion that we're trying to prove. Therefore, all that is to say that C is wrong. Of course, A is also wrong. We are on to D. An ecosystem cannot be sustainable if some of its soil is not nutrient dense. Now, we already know that a sustainable ecosystem requires nutrient dense soil. That was the A to B condition. We already know that from the paragraph. Now, D kind of takes it a little further. It says an ecosystem can be sustainable even if just some of its soil, even if just 1% of its soil is not nutrient dense. In other words, all of the soil needs to be nutrient dense. What that does is that kind of takes this necessary condition we already know and it makes it a little stronger. It makes it a little more potent. But it doesn't give us what we need. We're still missing this gap over here, and therefore that's not going to prove the conclusion, right? And therefore that is not the right answer. Again, if you know what you're looking for when you go through these answer choices, it makes your life a heck of a lot easier. Let's look at E. If chemical nutrients are recycled from dead plants and animals and released into the soil, that soil will be nutrient dense. So let's go ahead and look back at some of these conditions and see how that relates to our A, B, C, D down here. This last answer choice is telling us that if you have this, if the chemical nutrients are recycled, then the soil will be nutrient dense, right? So much like previous answer choices, what this is doing is it's taking a condition that we already know and it's reversing the necessary into a sufficient. Right? We already know that chemical nutrients recycled is required for nutrient-dense soil. Remember, as we keep saying, the end of the arrow, the way that we drew this out, and the way that these arrow notation diagrams would always be interpreted on the LSAT, the end of the arrow is required for the beginning of the arrow, right? So, as the paragraph told us, chemical nutrients recycled is necessary for nutrient-dense soil, right? That's what the last sentence told us, right? It says soil can be nutrient-dense only if these chemical nutrients are recycled, right? So E takes that necessary condition and turns it into a sufficient condition. It tells us that not only is C required for B, but C is sufficient for B, right? If chemical nutrients are recycled, that is sufficient to know that therefore that will guarantee that the soil will be nutrient dense. So it kind of takes this arrow, kind of makes a little detour, goes in the wrong direction, right? So that's not what we're looking for, right? It does not do anything to fill in this gap, which is, again, what we've known from day one. That's what we're looking for. Anything else is just a distraction here, right? And therefore, that's not going to be the right answer. It's very similar to a couple of other wrong answers that we've already analyzed earlier in this video. So hopefully now you can see how we've arrived at B as the answer. If we make B true, that allows the conclusion to be properly drawn. It is our missing assumption. Any of the others, if we make them true, are not going to prove the conclusion because they are going to leave this gap unfilled. So as you can see, with a question like this, all you need to do is either diagram it out the way that we did or at least visualize it as a bridge, getting from A to D, or sometimes it'll be A to C or A to F, whatever, depending on how many points they give you. and you have to sort of see what they gave you and find where the missing puzzle piece is, what the missing piece of information is. That's going to be the missing assumption that's going to get you to your conclusion. All right, that's it for now. Thanks so much for watching. Really hope you found this video helpful. If you did, let me know in the comments, and be sure to head over to masterlsat.com if you're serious about crushing the LSAT. I know you are. I can see it in your eyes. And until then, I will see you in the next video. If you found this video useful, don't forget to hit subscribe. And for thousands more clear LSAT explanation videos, go to masterlsat.com.